And here are the solutions to the final exercises for the course. Here's my solution to the signal question that I posed to you. I have a program whose sole purpose in life is to just go around this while loop, just sleeping for 1 second each time through the loop. And then at some point, if a signal 10 is received, then we can call the function called process_sig, which is this process up here, which simply does a date followed by a cal, and I've put a little blank line there just using echo just to make the output neater, and you'll see why in a moment. So let's run it and see if it works. Sig test, run it in the background, and it can just go off in the background and do nothing all by itself. And I know that its process ID is 10896, so I'll kill that with a -10 signal, 10896, and see what happens. And there is the date and the calendar. And I can do that again, kill -10, 10896, and there's my date and calendar again. And that will continue indefinitely until I get bored. Okay, now if I really want to kill the program and actually make it stop, I can kill it with some other signal. Just kill it by itself. That will send it a 15 signal, a sig term, and then, as you can see, that terminates the process. Okay, so that was working quite well. Now let's have a look at the course project. Okay, there were quite a few changes made to the project this time around, so let's go through them one by one. We need a temp file, and I've just decided I'm going to put that up the top. I don't have to put it up the top, but it's nice to do that just in case. The user might decide that the temp files should not go into the temp directory, they should go somewhere else, and so they can easily change that by changing this line right at the top of the file. And what else? Pause is the same, yes, no is the same, usage is the same. I now have a function called quit, which looks like this. And it says, do you really wish to quit now? And if they say yes, then I exit using the single parameter to the quit function. So the quit function actually takes one parameter, which is the exit code, to use with exit here. Now I actually have to store that away in a variable, because if I call one function from another function, then $1 gets overwritten. You can test that out for yourself if you like. Anyway, so I'm going to call quit. Quit is going to be my standard way to get out of the program. We'll obviously call quit whenever we receive a signal 2 or 3, and we'll also call the quit program whenever the user selects the quit menu option. So let's move on. Now I actually created a little function called heading because I didn't want to actually have to put out this code twice, and it's just those 2 lines of code there, just a couple of echoes. The reason I put them in a separate function is because otherwise I would have had to duplicate those lines of code. And again, I've got another function here which I've created simply so I don't have to duplicate code, and that is how to print out the actual records from the database. We're going to need to display them using the search option, and we're also going to need to display them in the view option. So rather than have those lines of code twice, I thought I'd put them in a separate function all by themselves, and this is what it looks like. It's a rather clever function. It reads information from standard input, this function, so you can actually pipe, using this example here, you can actually, for example, pipe information to this function from grep or from cat or from anywhere else. And what it will do is it will sort them, sort the standard input, sort the lines of input that it receives, and that's the sort option that we used before. Sorting via the second field, that's what the +1 means, sort via the second field, and the -t colon means that fields are separated by colons, and for each line we'll just simply display that in the awk way, and that's just cut and pasted from the awk line that we had before. And that's pretty much all that the print records function does. So print records and the one just above it, heading, are going to be used whenever we need to print out information about the records in our database. And now create hasn't really changed at all. View will have changed, because really now I just call heading, and then I cat the file name, and just pipe the results to print records, which, as we saw a moment ago, will sort the output and essentially pipe it to awk. And then all of that is collectively piped to the more program, so we see it one page at a time. So that's the view program. Obviously we also display how many there are. Now here's the new search program. We ask them to enter a pattern to search for, and I've also allowed them to actually not enter any pattern at all. They can just press enter at this point and they'll see all the records. Now I just use grep to see if there are any, and I don't actually display them at this point because I send all the output to dev null. I just check to see if there are any, and if there are, then I display them. Again, there's that call to heading, and now this time I'm calling print records again, but the input that I send to print records is the output from the grep program. So I'm going to grep, search for that string that they typed in, send that and send all that information to print records, and of course pipe all of that to more. Now I'm actually creating an exit status for this function here. Don't forget this is the do search function, and do search function is actually going to have an exit status which is going to be essentially the same as grep's. So we'll return 0 if we found some records, or we'll return 1 if we don't find any records, and that will help us with the do delete function, which is just coming up. So this little else here is the else from this if statement, so that'll be essentially saying if grep did not find any of those records in the file, then we'll just simply say sorry, there are none. And then we get down to the do delete, which will do the following. The very first thing it will do is we'll call the do search function, so it'll do all of that. In other words, it'll prompt the user to enter a string, and it'll display all the records that match that string, and then if that succeeds, in other words, if I did manage to find some, it will do a yes no, do you want to delete all these records? And if they say no to that, then we'll just simply return from this function because there's nothing more to do. So if we continue on, that'll be because they said yes to the yes no question. So now we just go ahead and delete the records. Now if this is a special case, I guess, that if they just pressed enter when they were asked for that particular pattern, in other words the string that they entered is empty, then just clear the file, because they've asked essentially to delete all the records, so we'll just start again with an empty file rather than doing any of the other complex processing down below. So we can say all the records have been deleted, and then otherwise if they did enter a string, then we need to use sed, and here is the use of sed. Now, so here we're going to be saying search for all the lines in the file that match the given string and delete them. And the results of that are going to go to our temp file, and that's our temp file from right up at the beginning of the program, and then we'll simply move the temp file back to the original file name. So that's why we needed a temp file, and all the records containing the text blah 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 have been deleted. And moving along, here are our trap lines. If the user types in Control-C or Control-backslash, then we'll call the quit function, which will say, do you really wish to quit now? And if we get a signal hang up or a terminating signal, then we will just exit the program straight away with an exit status of 0. And that's pretty much it. I think there weren't many other changes other than the fact that in the loop, in the main loop, we now can just simply call the quit function rather than here putting the yes no function, do you really wish to quit? We can just call the quit function. And that's about it. So let's test it and see if it works. Okay, so here's the program running. Now what I'll do is the very first thing I'll test is to see whether that trap function is working properly. So I'll type in Control-C now. Okay, so I'm hitting Control-C on the keyboard, and I get, do you really wish to exit? Yes or no? Well, that's good. And if I say no, then, well, nothing's happened, and that's the right thing that's supposed to happen. I'm back again waiting for another answer. So I could try it again, Control-C, do you really wish to exit? And this time I say yes, and I've exited with a status of 3. So I'm back in again now. The trap facility is clearly working. Now I've created some records. and those are the 3 little simple test records in the database. And what I'll do is I will search for ones that have a B in them, and that was working, and notice they are being displayed in exactly the same way as they were being displayed before. So now I'll test out option number 4 to delete records. So 4, enter the pattern to search for. How about C this time? Delete all these records, and I'll say yes. All records containing text C deleted. Okay, let's see if that's actually true. We'll view the records, and only A and B remain. Okay, so that seems to be working. So as you can see now, we've got a program that has got no duplicated code. Everything has been put into functions. All 4 menu options are working. The program will gracefully handle any interrupts that it receives, or at least any common interrupts that it will receive. And it is a rudimentary and simplistic database, but it is actually a working database, which hopefully demonstrates all of the techniques that you would use in a typical shell script. So that completes the course. There is one final movie coming up, just the summary and completion movie.